We probably want to do it before spring break, though, I would think. Like maybe Friday, huh? Yeah. Maybe we'll do that. Okay. All right. This is week 11, Tuesday, semester 2, quarter 4 for geometry. This is to prepare for a quiz that's going to be up tomorrow. It's on vocabulary. So the first one I'm going to go over is the following. Angle. It's usually the space in between two rays. Like, for example, if you take a look over here, do you see the vertex is the Y, which is the pointy part? YX is a ray. A ray is like with a dot and an arrow. A Y to a Z, that's another ray, okay? And together, when they're together with a vertex Y, it creates an angle right here. Do you see that? That's an angle, okay? So the way that you read this angle is angle X, Y, Z, like the Y is in the middle, right? Or Z, Y, X. Do you see that? You can't say, oh, this is angle Y, Z, X, because that doesn't make any sense. That's talking about this part right here. Do you see that? And you want to go this way. Okay. Vertical angles. Vertical angles, you look for the X. Okay. Do you see the X right here? When you have the X, what that means is that the X right here, when you have the X, you're looking for the opposite angles. Okay. So like in this case, AED is the first vertex angle, and that's equal to the opposite angle, BEC. Do you see that? Yeah. Those two angles are acute. Okay. Another pair of vertical angles is AEB is congruent to CED. They're opposite and they're congruent and they're obtuse. Okay. All right. Next one, supplementary angle are when you have two angles and they're together. So they're supplementary. They're also adjacent because they're next to each other. They're adjacent because they share. Do you see where there's CA right there? They share that side and they create a straight line. These two angles are supplementary because they add up to a straight line, which is 180 degrees. Another way of saying supplementary is also linear pairs or straight angle, okay? Complementary angles are like supplementary angles, except you have two angles that add up to 90 degrees. Like, for example, do you see the 90 degrees right here, ABD right here? But they're also adjacent. They're adjacent because they share BC. They share a side, okay? So ABC plus CBD equals 90 degrees. So they're complementary angles, okay? Next word is adjacent. Adjacent is when you have two angles and they share a side. Like, for example, ABC is adjacent to CBD, or CAD is adjacent to CAB because they're sharing the side right here. Do you see that? Next one is linear pairs. Linear pair is when you have two angles that add up to 180 degrees. They're just like supplementary angles. Okay, so like this one, for example, KFG is a straight angle. It's 180 degrees because it's straight, right? Yeah. So the two angles, KFH is obtuse. That angle is adjacent to angles HFG, which is acute. They share FH, so they're also adjacent, but they're also supplementary and linear pairs because they add up to 180 degrees. Okay? Yeah. All right, let's move on to the next part. Except I can't. Why can't I move? Okay, next one. Let's take a look. Describing sides of an angle. There are three different ways of describing it. The first way is scalene, okay? Scalene means all three sides are different length. Like, for example, triangle ABC, okay? This is scalene because this side is 1 tick mark, this side is 2 tick marks, this last side is 3 tick marks. That means all three sides are 3 different lengths, okay? If you have the same type of tick marks, it means they're congruent. But in this case, all three sides are different. If two sides are the same, what is that called? Starts with the I. Isosceles. Isosceles. Isosceles triangle is when two sides are equal. So in this case right here, which two sides are equal? GI is a side. And what other angle? Or what other side? H is just, okay, you need 2 letters for a side, right, sir? 3 letters for an angle. GH is this side right here. IH is this side right here. You're saying these two sides are the same? Really? I don't think so. Do you see how this one has 1 tick mark? Yeah, GI and HI. There needs to be in alphabetical order. Okay? GAH is not the same. It has only 1 tick mark. When all three sides are the same, what would you describe it as? Starts with E. Equilateral. Equilateral is when all three sides are equal. Do you see how with RST, triangle RST, all three sides are equal? They have only one tick marks on all three sides. So once again, what are the three different ways of describing the side? Tell me right now. Scalene. Scalene. What else? Isosceles and? Good. When all three sides are different, what is that called? Scalene. You need to sit up straight and pay attention. No, you're not. You're not getting this. I already described this twice now to you. If you really paid attention yesterday, you should have gotten this already. When all three angles are the same length and they're equal, what is it called? Again, not getting it. Start with the E. If it's all three are equal, it's equal. Lateral. Lateral means sides. Equal means equal. Do you understand that? When two sides are the same, what is that called? Isosceles. When three sides are all different, what is it called? When all three sides are equal, what is it called? When two sides are equal, what is it called? You need to memorize that tonight. Now we're going to talk about angles of a triangle, okay? If something is bigger than 90 degrees, what do you call it? Obtuse. Or, yeah, obtuse. Or what if something's smaller than 90 degrees, what do you call it? Acute. I think about acute, like cute. Cute means small, right? So smaller than 90 degrees. So this right here, this is a cute triangle right here, because all three angles are smaller than 90, okay? If something is bigger than 90, when I say bigger than 90, like bigger than the corner of a piece of paper, then it is called writing or obtusing, right? Like this right here. If it equals exactly at 90 degrees, like the corner of a paper, what is it called? Equal to 90.
Oh, right angle.
Right angle. If it equals 180 degrees, like a straight line, what is that called? No. Straight angle. Straight angle. If it equals 180 degrees, it's called a straight angle. Straight, 180. Congruent segment. Congruent segment is basically the sides of a triangle. Okay, it has two dots at the end. Do you see that right here? Okay, this right here is called congruent segment. Congruent angles means that the angles are equal. Congruent figures means that shapes that are equal. Polygon means it's a shape with many what? Just read it. What does it say?
It has shapes that are equal.
No, it's not what it says. Polygon. What does it say? Yeah, poly means many. Gon means a number of sides. So many sides. Regular polygon. All sides of the angles are equal. So the sides are equal and the angles are equal. Like an equilateral triangle is a regular polygon. Perimeter of a figure. What would you define the perimeter of something?
I would have to length times width.
No, that's not. Perimeter of a figure. Perimeter of a figure is like you building a fence around something. To build a fence around something, what would you need to do? You add all of the sides together, right? To build a fence. Area of a figure is like, it's like you painting inside the figure, okay? Like how much paint do you need? Perimeter is how much fencing do you need? Do you see the difference there? Volume is like if you're to pour water into a shape, okay? That's why it's length times width times height, okay? Because you're pouring water into it. So which one there is like you building a fence? Which one is like you pouring water into something? Nope. Water, pouring water. Yep. Which one is like you painting the inside of it? Area. Okay. Another way of thinking about area is like if you need to cover a present, like you want to gift wrap it, for example, how much gift wrapping paper would you need? Does that make sense? Okay, surface area is exactly that. So with surface area, it's area of all the side added together. Okay, for example, like gift wrapping. It's like gift wrapping your present. Does that make sense? Prism is a 3D shape, and that could be a rectangle, rectangular, square, or triangle. Okay? Pyramid is a square on the bottom and triangle on the side. So here is a shape of a pyramid. Do you see how there's a square on the bottom and the four sides are on the four sides? Do you see that? Prisms, what are the three different shapes that you can have for prisms?
Um,
Not pyramid. It could be a rectangle, triangle, and square. Remember that? So look at this right here. Do you see with a different type of prism? This is a triangular prism. The base is a triangle. This is a rectangular prism. This is a square prism. It gets more complicated when you have pentagon, hexagonal, octagonal prisms, and also trapezoidal prisms. But those are like more difficult things. Right now, all you need to worry about is triangular, square, and rectangular. Do you see that?
Yeah.
Okay. Pyramid is when you have a square on the bottom, but then the four sides are triangle. Okay. All right, quadrilateral is any four-sided shape. So any shapes you can think of that's four-sided falls into the quadrilateral. Like quadrilateral is the mom that gave birth to all the four-sided shapes. What are all the four-sided shapes you can think of on the top of your head?
um,
Yep, keep going. That's four sides. Go, keep going. What's another? Keep going. Diamond, yeah, that works. Diamond, kite, rhombus. Okay, what else? Trapezoid and parallelogram. So a rhombus is like a square, except it's kind of pushed over. Okay. All right. And then a parallelogram is like a rectangle, but it's pushed over a little bit. It's slanted. Okay. So all these are parallel lines. Two lines that have the same slope. They're like railroad tracks. Okay. Perpendicular lines. They create a 90-degree angle. Okay. Mm. Okay. And then parts of a circle. Let's go over that. Okay, parts of a circle. Radius, diameter, circumference, area. These are all parts of a circle, okay? So for example, take a look over here. If you're looking at the radius right here, Radius is from the center to the edge of the circle. Do you see that? To the side of the circle or the circumference of the circle? So AB, AX, AC, these are all radius or radii. Diameter is from one side of the circle to the other side of the circle, but it has to go through the center. Do you see that? Circumference is just the space, or it's just like how long it is around the outside of the circle. Okay. And that's basically it. I would just suggest that you go ahead and study this a little bit more, and so that way you can understand this a little bit better. Okay.